Hello Year 10s and welcome to Remote Learning Week 6. Use it or lose it.
Use it or lose it.
Thank you for putting your foot in my face. Now, I'm going to go through some examples of the kind of questions you'll see in the problem sets that are in this task. It's not meant to be... Thanks, Leon. It's not meant to be an exhaustive list of examples, just maybe enough to get you started if you've got no idea. If you look at them and you're still struggling, please send your teacher an email or see them in your Google Meets and ask them to go through some examples there. Okay? Good luck, and hopefully we'll see you back at school soon. Bye-bye.
Bye-bye.
As you've probably read in this learning task, your goal for this week is to complete these problem sets, 3 of them. There's a level 1 sheet and a level 2 sheet. Each has 4 in them. That gives a total of 8 problem sets, of which you have to pick 3. You do one day, another the other day, and so on.
Okay.
Thanks, Leon. Now, I'm going to go through some of these examples because there might be some stuff in here that has been forgotten due to the depths of time.
Okay.
Thanks, mate.
Welcome.
All right, first thing that you may have forgotten is how to convert from improper fractions, where the numerator is larger than the denominator, to mixed numbers, which is a whole number and a fraction together. Basically, the idea is that you can think of this 11/8 as 8/8 plus something 3/8, because 8 plus 3 equals 11, and you know that 8/8 is 1, and you've got this 3/8 left over. Therefore 11/8 is 1 3/8. The easier way to do it when the numbers are larger, like here on the left, is to count by whatever the denominator is. So I'm going to count by 5s. Check this out. 5, 10, 15, 20, 25. 5. Next one's 30. It's too much. So 5. And then what's left over to get from 25 to 28? Okay? Because in the background, what you're thinking is that's 25/5 plus 3/5. But like I said, simplest way is just count by the denominator, and then the fraction bit is whatever's left over. We can do one more. Let's say something like this. 31/6. Count by 6s. 6, 12, 18, 24, 30. 36 is going to be too much. It's 5 again. It was 30. What's left to get from 30 to 31? 1. Okay. Done deal. All right, next up we got percentages. A lot of different ways to do this. I'm going to give you the surefire method that works every single time. Take your percentage, put it over 100. Of means times. 30 means 30. Put this into your calculator. It will spit out 6. If you don't know how to put a fraction into your calculator, basically on the class pad, which is the calculator you'll be using next year, there's a fraction button. Basically fill in the boxes. On the scientific calculator, there's also a fraction button, fill in the boxes. If you don't have one of those calculators, still doable. You need to enter something that looks like this. Bracket 20 divide 100, close, times 30. This 20 over 100 is here, 20 divided by 100. Put that into anything, even a phone, and it'll spit out for you 6. Now, as I said, there's many methods to do this. You might think, oh yeah, that's easy because 10% of 30 equals 3, therefore 20% equals 6. Certainly true, but what are you going to do when it's 28% of 73? You're going to use the method that always works. 28 over 100 of is times. 73 is 73. This goes straight into a calculator. I'm going to do it right now in real time. Fraction button, 28 down 100 times 73, 20.44. Done deal. Next, these ratio questions. You might not have explicitly seen anything like this before, so I'm going to show you a surefire method to get these ones right. Here's what we got to do. We start with the total number of pieces. The total number of pieces. What do I mean by that? This side of the ratio there's 2 pieces and this side there's 3. So in total we have 5 pieces. We're going to draw up a nice little circle that we're going to split into 5 because there's 5 pieces. Now, if you imagine that this circle has 60, that's what the question says, then each one of these little pieces, each piece, is going to have 60 divided by 5 in it. Okay? Now what about the ratio bit? Well, one person's getting 2 and another person is getting 3. What does the purple person get? 2 lots of 12. Each piece is 12. What's the blue person getting? 3 lots of 12. What's 2 times 12? 24. What's 3 times 12? 36. And then you can check if you're correct. That number plus that number needs to equal that number because the question is asking us to split this amount into some ratio. The numbers will always work out nice, so don't stress too much. Let's have a look at this next example, the purple example. How many pieces in total? 6 pieces. Draw up a circle. I'm going to split it into 6. How are we going to do that? Well, you can have 3 pieces. Doesn't have to be perfect. Each of these pieces we can split into 2 and then we've got 6. Okay. Each piece, well, there's 48 in total and we're dividing it by 6. So it's 8. One person is getting 1, 2, 3, 4, 5. And the other person is getting 1. How much does green get? Well, 5 times 8. How much does blue get? 1 times 8. 40 to 8. 40 plus 8, 48. Done deal. Next up, we're going to be talking about finding unknown angles inside a triangle. I'm what this relies on is that angles inside a triangle add up to 180. So with that neat little fact, we're going to very easily be able to solve any of these things that come up. Okay, I've put up this really basic example. You might already be able to see the solution just from the numbers, but anything harder is just going to be very, very similar. Okay, so you need to find the value of x that makes all of this stuff add up to 180. Okay, so as an equation, you might already be able to see, like I said, we've got the following: x plus 60 plus 40, all of these added together, equals 180. And then, if we're going to do some simplification, 60 plus 40 is 100. If we're going to subtract 100 from both sides, we're going to end up with this. Done deal. Okay, we're getting down to the pointy end now. Got a few things that some of you might struggle with, but that's okay. If you need help with this, just jump onto your video meet and your teacher will be there to guide you through. I'm going to go through this example.
Yes.
Transpose 4y minus 5x equals 3 to make y the subject. That is to say, we want y equals. Our goal is to have y equals something. And we've got to move all the pieces around to make that happen. What we do is called the balance method. You might have seen this before. We always need to be doing the same thing to both sides. So just keep in mind that that y is what we want by itself. And it's still got some other stuff kind of hanging around it. And we work outside in. So I'm going to get rid of this negative 5x first. And the way I'm going to get rid of it is by adding 5x. But anything I do to one side, I have to do to the other side because it's balance. What is it, Leon?
Balance, balance, balance.
Balance. Stay out of the camera, please. Okay. Notice that the 5x is gone from the left-hand side because negative 5x plus 5x equals 0. That's the whole point of what we're doing. Okay. Still keeping in mind that we want y equals. And at the moment, we have 4y equals. So the way to undo that, it's 4 times y, we're going to undo it by dividing. 3 plus 5x divided by 4. And really, in your head, you should be thinking, we've divided the left-hand side by 4 and the right-hand side by 4 also. This cancellation has taken place, so we're left with y on the left, and 3 plus 5x, all divided by 4 on the right. Okay. Okay, we're going to do one more. Transpose 2x plus 3y equals 7 to make x the subject. Put a little box around x. That's what we want it to be equal to. We want x equals something. So let's get rid of all the stuff around the x. rewriting the equation here. Just that this is the one we want. And we're going to go outside in. I'm going to subtract 3y from here. And the same from the other side. Because of what, Leon? He's gone. He's not paying attention. It was balance.
Yes, I am.
Yes, you are? Good on you, mate.
That's looking at some things.
Just looking at some things?
Mm-hmm.
Okay, we've got 2x equals 7 minus 3y. We want x. Gonna divide both sides by 2. Bang, bang. Oh. X equals 7 minus 3y. All divided by 2. As required. Okay, now we're going to talk about factorization. Factorization. Name of the game here is to look at the terms that you have and ask yourself the question, what is the biggest thing? Could be a number, could be a letter, could be a combination, that goes into both. Biggest thing that goes into 2x and 8 is 2. You need a bracket. And now you say to yourself, well, if you were to expand this, expansion is the opposite of factorization, what goes in the bracket so that you end up with 2x plus 8? That is to say, 2 times what equals 2x? X. 2 times what equals 8? 4. Okay. Similarly for this example on the right here, what's the biggest thing that goes into both? It's not a number this time. It is x. X times what equals x cubed? Well, yes, Leon.
I love you.
Oh, thanks, mate. I love you too. X times what equals negative 3x? Negative 3. Done deal.
I love these pajamas.
That's great. Okay, last one. Simplifying algebraic fractions. This is just like normal fractions. Maybe you've struggled with normal fractions in the past. Maybe this will help you with that. Who knows? How do we add two fractions together? Well, they have to have the same denominator, don't they? So, easiest way to do it is just go 3 times 4. In this case, 3 times 4 is 12. So 12 is going to be our common denominator. The way we can make this 12 is by timesing by 4. Whatever you do to the bottom, you do to the top. To get this one to 12, we have to multiply by 3. Okay. 8 times 4 is 4a. 3 times 4 is 12. 8 times 3 is 3a. Nice and quiet, please, Leo. Seriously, just like a classroom here. Now that we've got the same denominator, the way you add the fractions is by adding the numerators. 4a plus 3a, 7a. Beautiful. All right, next example. What is the common denominator of 3 and 2? Or the lowest common denominator? Well, it's going to be 6, right? 3 times 2 is 6. How do we get that to equal 6? Times by 2. How do we get 2 to equal 6? Times by 3. What is 2a times 2? 4a. What is a times 3? 3a. 4a minus 3a, 1a. We don't write 1a, do we?
No.
We just write a. A on 6. Goodness me, what a long video. Thank you very much if you've watched the whole thing. As I said before, if you're still struggling with any of this stuff, please send your teacher an email. They'll be more than happy to assist you. Or alternatively, log into the Google Meets where you normally have a class, and your teacher will be more than happy to assist you there. Have a nice day, and good luck. You have anything to say to the kids at Hazel Glen Leon? Say it.
Bye-bye.
Bye-bye.